All right, let's see what you got.
It's like, which is equivalent to root 45.
What does it say?
But I think I have it open somewhere else.
Or if you have the question in front of you, just tell me and I'll write it on the whiteboard.
It's this.
Which of the following is equivalent to, okay, all right, this one. All right, so the idea on this question is to ask yourself, what's the biggest perfect square? You know what a perfect square is, right? One squared, two squared, three squared, four squared, five squared, six squared, right? And so on, right? These are your perfect squares. What's the biggest perfect square that goes into 45? So which one of these goes into goes into 45? Which one of these numbers, which one of these uh which one of these perfect squares goes into 45?
6.
Well, six is not on the list, right? This is one squared, two squared, three squared, four squared. This one, right? That one goes into 45, right? So we can write root 45 as what? If we break it into two radicals, what is it? Root 9 times root 5, right? 9 times 5 is 45, right? So you can write it as 1 or you can break it into 2. And then what's the root of 9?
3.
3 root 5. 3 root 5. Okay?
Why is it 9?
Because why is this one 9?
Yeah.
The idea is the general idea is to break down the root 45, right? So we want to look at our perfect squares, right? This is 1 squared, this is 2 squared, this is 3 squared, and so on, right? We want to look at these numbers on the left to ask us what's the biggest one of these that goes into 45. So we know it's 9, right? So the idea is to break down the root 45 into two radicals, this one and this one. And then the next step would be to ask yourself, what's the root of 9? We know it's 3. So the idea of this question is just to break down the radical into something simpler. Like, you know how they say simplify? All we're doing is simplifying the root 45. But let's before we go on, let's try another one. Let's try another one. What about this one? Once you see a few of them, you'll get the idea. What's this one? Root 18. What's that one? What's the biggest perfect square that goes into 18?
Is it 9?
9. Yeah, exactly.
Or
Root 9 times root 2, right? And we know that root 9 is 3. So 3 root 2. Okay, what about let's say what about 48? Root 48. What's the biggest perfect square that goes into 48? 16, right? Root 16 times root 3, right? What's the next line? What's root of 16?
4 root 3?
There you go. 4 root 3. Exactly. Yep. Simplify. That one would be 4 root 3. 4 root 3. You cannot simplify root 3, but you can simplify root 16, right? All right, let's go through a couple more. Right. Let's see here. What about root 98? What about that one? Yeah, 9 squared is 81. 100 squared. I mean, 10 squared. Those are your perfect squares, right? These numbers. What's the biggest perfect square that goes into 98? root 49, right? Root 49 times root 2 is what? 7 root 2, right? Get the idea?
Yes.
The idea is just to break it into multiple radicals and then simplify one of them. Okay. All right, let's go to the next one. All right, click that first one. All right. Okay, yeah, 121. What's that one? Is there a number that times itself is 121? Yeah, that's just 11.
So
Yeah, that's just 11. That one's just 11. Right? 11 times 11 is 121. Okay, what about this one? 160. What's the biggest perfect square that goes into 160? Your biggest perfect square, your perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, and so on, right? Which one of these goes into 160? The biggest one that goes into 160.
it's a 100. Or
Well, 100 does not go into 160 though, right? But 16 does, right? This one does, right? So write it as two radicals, 16 there and 10 there, right? And then just break down this one. So what is that?
4 root 10.
Yeah, exactly. C. Yep. All right. What's the biggest or actually what's that one? What's that one there right there?
12.
Yeah, that one's just 12. You got some more questions you want to go over? Or you want to try is there any more radicals we can try?
X.
Radicals and rational. Yeah, try one of those. Okay, this is just a simplification. All right, what's that one? Take that 3, take this 3. So look, 2x 3y 4 z5. The 3 would multiply that by 3, that by 3, that by 3, and then this 1 right here, multiply that by 3. So what is that? So the 3 goes to every term, goes to that term, this term, this term, this term. Just follow your exponent laws. So it's 2 to the 3. What's 3 times 3?
9.
So this will be 9. X to the 9. What's y? What's 4 times 3?
12.
And then what's the z? What's this one?
15.
There you go. And what's 2 times 2 times 2?
8.
There you go. So 8, x 9, y 12, z 15. We have that one? There you go. Just follow your exponent laws for that. This one, what is that one? So same thing. The 2 goes to the 3, and it goes to the a2. Now just simplify this. Oh, no, wait a second. That's 3 to the a. My bad. My bad. I got old eyes. Okay, so let's try it again. It's 3 to the a all squared, right? So same thing. Just multiply that and that. 3 to the 2a. We have that one? No, we don't have that one. Okay, so what's that written in a different form? Okay, so 3 to the 2a can be written how? What's this? What's just that part simplified?
9.
9a. Do we have that one? 9a? Yeah, B. All right, what do we? Okay, so same idea on this one. 2x to the power of 3 would be what? Follow your exponent laws. 2 to the 3x, right? And what's 2 times 2 times 2?
8.
8 to the power of x. This one. All right. Go to the next one. Okay, this one. What are we going to do with this one? Which of the following values is equal to the above? Okay, so we're adding them, right? So let's see here. How can we rewrite 6 to the half? What is that the same as? That's just the same as root 6. Okay. How can we rewrite 6 to the 3 over 2? What is that? Okay, so let's back up for a second. See the 1 right here and see the 2 right here? Where does the 1 go? Where does the 2 go? So the number on the bottom here goes there. So there's your 2, and the 1 goes on the outside. So when you write radical x, there's an imaginary 2 there. We don't write it. It's just understood that it's there, okay? So anytime you see, say, x to the half, that just means root x, okay? The 2 is really there, and the 1's on the outside. So going back to this, what is that equal to? Where does the 3 go? Where does the 2 go? The number on the bottom goes on the inside. The 2 goes there. 6 goes there. And everything to the 3. Okay? So this question is the same thing as root 6 plus root 6 to the power of 3. Okay? We don't need to write the 2 there and write the 2 there. We don't need to do that. Okay? So what does this question equal then? Oh, I forgot the 3 there. 3. Can we simplify it like that? Um, all right, let's try a different way. Let's try it a different way. When we add that like that, we can also write it like this. Have you seen this before?
I'm not sure.
No. It's really just like exponent laws. It's more an advanced exponent law. All right, so let's go back. All right, let's see here. Okay, so going back to this right here. Let's think about how we can do that. Um, so it's the same thing as root 6 plus root 6 to the power of 3. How can we simplify that? What is Now, if this was multiplication, right, we would just add the exponents, but it's addition. So what could we do? One and a half. This is 1.5, right? 3/2 is 1.5, and this is half, right? 1.5 plus half is 2, but that's not right. Actually, this one is going to be, it wouldn't be 36 because it's addition, not multiplication. Try C. Okay, 7√6. Okay, let's see how they're getting that. Okay, let me erase this so I can. This one I wasn't sure of actually. This one I'm not sure of. Let me see the explanation. Okay, so what they're saying is, okay, they're breaking it down. Okay, they're breaking the 1.5 down. See, this is 1.5, right? Now they're breaking the 1.5 into half and 1. Okay, so then they break down the 1.5 into half and 1. Okay, now you can factor out the. Now you can factor out the half. Okay. Okay. All right, let's try another one. Is there another one like that? Or no? Okay, not really. And the expression above is equal to, if the expression above is equal to y to the a, so this is y to the a, for all positive values of y, what is the value of a? Okay, so let's simplify that. Fourth root of y times times the root of y equal over third root of y. Okay, how do we simplify the top there? How can we rewrite this right here? What is this? Y to the what exponent? It'll be 1/4. Okay. 1/4. This is y to the 1/4. This right here is y to the 1/4. So what is this one right here? Y to the what?
1/2.
Yep, exactly. 1/2. And what's this one on the bottom? Y to the,
1/3.
there you go. Okay, so now we got y to the 1/4 times y to the 1/2 divided by y to the 1/3. What are we going to do with this and this?
Add them.
Exactly. Add them. So what's 1/4 plus half?
3/4.
1/4. Yes, exactly. Okay, so now we have y 3/4. Oh, sorry, erase this, right? 3/4 divided by y to the 1/3. Now, what are we going to do with this and this?
Subtract.
Subtract. What's 3/4 minus 1/3? 3/4 minus 1/3. Just change it to 12, right? This is 9/12 minus 3/12, right? Which is what? No, 4/12. 4/12. Which is 5/12, right? So y to the 5/12. So what is a? If that equals y to the a is 5/12. So just type 5/12 right here. You get what we did there?
Yeah.
All we did was rewrite the numerator and denominator, then use our exponent laws. Okay. All right, you do this one. Just rewrite the one on the bottom and then subtract your exponents. Yep, 1/3, right? And this is 1 right here. So what's 1 minus 1/3?
2/3.
Yeah, so which one? Is it B or is it C? So this is the same thing as x to the 2/3, right? So it'll be C. Okay. So just remember that x to the power over 2/3 can be written two different ways. It could be written like this, the 2 there, and the 3 there. That's the same thing as the 2 on the outside or the x3 on the. So this is the same as this, just different form. Okay. The 3 could be on the outside of everything, or the 3 could be on the inside there. Okay. It means the same thing. Okay. All right. Next one. All right. This one was like kind of like the question from a few minutes ago. All right. What are you going to do with that one? So this one, now we have a plus sign on the top there, right? We have a plus sign. So do like the question from a couple minutes ago. What we're going to do is rewrite this one. We're going to erase this. So, okay, so the y squared, we're going to rewrite as y times y, right? This part is y squared, right? So we're just going to rewrite it like that. And then we're going to, okay, then we're going to leave the bottom, y to the 2/3, right? Now we're just going to factor out a y1 on the in the numerator. So if we factor out a y1, we'll have 1 plus y, right? And then on the bottom, we'll have y to the power of 2/3. Okay, so the y's will cancel, right? The y's will cancel. No, 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 my bad. No, the y's will not cancel. How do we simplify this? Actually, let's rewrite this line. So the y 2/3, this right here, the y 2/3 goes into both that and that. All right, so let's rewrite it. So it's really like y over y to the 2/3 plus y squared over y 2/3. It's kind of like this. It's kind of like 3 plus 5/2, right? That's the same thing as 3/2 plus 5/2, right? The 2 goes into both of them, right? So same thing with the algebra. So what's that? What is that line simplified? So what's 1 minus 2/3? What's this one right here? 1 minus 2/3 is how much?
1/3.
So y 1/3. And then what's the second one? Y plus y to the what? 2 minus 2/3. 2 minus 2/3 is the same thing as what? 6 over no, 4/2. I meant 4/2. No, put this one over 3, right? What is that? 2, this is 6/3 minus 2/3, right? Which is 4/3. So do we have that one? 1/3 plus 4/3. This one. Okay. These questions are just like rewriting those. It was. Oh, we did it wrong. Wait a second. Let's go back. Did I do something? Did we do something wrong there? 1 minus 2/3 is 1/3. And then 2 minus 2 over 3 is, did we do this wrong? 2 minus 2 minus 2 over 3. Did we do that wrong? This is 6 over 3 minus 2 over 3, which is 4 over 3. That's right. Which one did they say it was? 1 over 3 plus 4 over 3. Isn't that what we got right here? Oh, no, they're saying it's D. They're saying it's D. All right, let's scroll back up to the original question. Okay, y plus y squared. Oh, is this negative? My bad. This is negative. Oh, that's why. My bad. I didn't see the negative. Sorry. Sorry, I didn't see this negative. So this will make this, right, this is negative there. All right, yeah, so the subtraction will be different, right? Sorry, my bad. I didn't see this negative sign here. Same process. We just need to subtract differently, okay? Same process, but on this line, we're going to say so if we go back to this line, this is negative here and this is negative here. So what's on this one right here? What's 1 minus minus 2 over 3? That's the same thing as 1 plus 2 over 3, right? Which is the same thing as what?
5 over 3.
Yes. Yeah, exactly. So this one will be 5 over 3. And then on this one, what's 2 minus 2/3? That's plus, right? So 2 and 2/3 is the same thing as what?
8 over 3.
8 over 3. Yeah, exactly. There you go. Yeah. All right, let's go next question. All right. Okay, what about that one? What are we going to do with that one? 1 over 8 to the negative 2/3, right? Okay, so the negative 2/3 goes to both numbers. So there's your 1, there's your 3 squared, there's your negative 2. That's the numerator. Same thing with the denominator. Root 8. The 3 goes on in there, and the negative 2 goes there. Okay. What is this? What is this equal to? What number times itself 3 times is 1? 1, right? So 1 to the negative 2. What number times itself 3 times is 8?
2.
Exactly. So 2 to the negative 2. Now, what's this simplified? So 1 to the negative 2 is the same thing as 1 over 1 over 1 squared, right? Which is just 1. And what is 2 to the negative 2? 1 over 2 squared, which is 1 over 4, right? So this is 1 over 4. How many quarters are in 1?
4.
There you go, 4. Okay, so the idea is just to simplify. The hardest part on that question is just rewriting the numerator as that and rewriting the denominator as that and then simplifying. Okay. As long as you follow your exponent laws, you'll be okay. Or you got some more radicals you want to try? Or anything else? Okay. All right. So just for that one, just collect your like terms. Your like terms are the root p's, right? So this one goes with this one, and your root 3, this one goes with this one. Okay, so collect your like terms. So 8 root p, is it going to be, and then you've got 3 root p. Is this going to be a minus sign or a plus sign right here?
Plus.
Well, it's plus on the right side. So when you move it to the left side, it's going to be the opposite sign. So
Oh,
minus, right? And then the root 3, that's on the right side already. You've got the root 3, and you've got 2 root 3. What's the sign in the middle? Plus or minus?
minus.
It's minus on the left side. So when you move it to the right side, it'll be the opposite sign, plus. How you guys, you know how you guys are taught in school, like x minus 5 equals x plus 3? So what you guys are doing is adding 5 to both sides, right? So it's kind of like it's doing the same thing, just when you're moving terms to the opposite side of the equal sign, just remember that your signs will change. So now just simplify. What's 8 root p minus 3 root p?
5 root p.
Yeah, 5 root p. And then what's the right side?
5 root 5. 8.
So this is 5 root p. And what's the right side? 1 root 3 plus 2 root 3 is how many root 3s?
3 root 3.
3 root 3s, yep. Now what are you going to do to both sides? What value of p? You're trying to solve for p, right? So divide both sides by 5. Divide both sides by 5. The 5s will cancel, right? So you have root p equals 3 root 3 times 5. So that's root p. So how do we get p?
Square.
Square both sides, exactly. Square both sides. If you square root p, that's just p. Now square 3 root 3 over 5 squared is what? What is that? 3 times 3 is 9. Root 3 times root 3 is 3 over 25, right? And what's 9 times 3? Do you see how I'm doing this?
Yes.
It's really just like this. 3 squared root 3 squared over 5 squared. This is 9. This part is 9. This part is 3. So 9 times 3 over 25 is 27 over 25. Okay. So that one, just collect your like terms and then solve for p. All right. All right. Before we go to the next one, let me ask you this. What's this? What's 5 root 5 over 3, all that squared? What is that? What's that equal to? Square all 3 terms. So this is 5 squared. This is root 5 squared. And 3 squared on the bottom. So what is that? 25 times 5 over 9. Okay. Whatever that multiplies out to be. Okay. Do you understand that?
Yes.
All right. It's really just your exponent laws, right? When you have something like there's an exponent law that says something to the effect that if you have A there, B there, and C there, it's really the same thing as A3, B3 over C3, right? Or no, sorry, two, right? Just square all three terms, right? All right. All right, what is the least value of y that is a solution to the above equation? Okay, so for this, we are going to do what? How can we do this one? If we do it like this, let's try this way. 15y minus 5 root y equals 0, right? Can we factor this? What can we take out?
The 5.
Take out a 5, so we'll have 3y. We'll have 3y minus root y, right? Equals 0. Now what? This part right here has to equal 0, right? This has to equal 0. So 3y minus root y equals 0. So how do we solve that for y? So it has to be 0, right? 3 times 0 minus root of 0, that's 0, right? So it says the least value of y. So if we take the 1/3 and plug it into here and here, would that equal 0? We're just testing out the answers. If we take the 1/3 and plug it into right there and right there, will we get 0? Is 15 times 1/3 minus 5 times root of 1/3, is that 0? Question mark. That's 5. 5 minus 5 root 1/3, is that 0? No. What about the 1/9? If we plug 1/9 in right here, 1/9 in right there, is that 0? So if we go 1/9 there, 1/9 there, 15, what's 15 times 1/9? 15/9 is what? 5/3. 5/3 minus, actually, this part is, what's the root of 1/9? 1/3, right? And then 1/3 times 5 is 5/3. So this one does check out. So all we're doing is just testing each answer. So this one checks out. This one checks out. What about 3? Plug 3 in there. Plug 3 in there. See if it equals 0. 15 times 3 minus 5 root 3 does not equal 0. So this one does not check out. So what's the least value? Which one's the smaller, 0 or 1/9?
0.
Yeah, 0. So check A. All right. All right, so this one, what is the sum of all solutions to the equation? Okay, collect your like terms, solve for t, and then add the solutions. So something like this. Root t plus 5t equals 6 root t. Okay, so what am I going to do? This and this are like terms, right? So root t and 6 root t. What's the sign in the middle? Plus or minus?
Fine.
Minus, yeah, minus. And then plus 5t equals 0, right? So what's 1 minus 6? That's negative 5 root t plus 5t equals 0, right? Now what? What are you going to factor out?
5.
So if you factor out on 5, what do you have on the inside? Negative root t plus 1. No, plus t, right? Equals 0. So for this to equal 0, this part right here has to equal 0. So negative root t plus t equals 0. So then if we, how do we solve that for t? What we could do is, trying to solve that for t, right? T plus 5t equals 6 root t. So we subtracted the 6t. Negative 5t plus negative 5 root t plus 5t is 0. We factor out a 5. So this part has to equal 0. Okay. So then we know that negative root t equals negative t, right? Now square both sides. If you square, what's this? What's negative root t all squared? What is that? It's just t, right? So t equals, and then what's negative t all squared? This is t right here, and this is what, t squared. So t equals t squared. Um, t cannot equal t squared, right? What is the sum of all solutions? What is the sum of all solutions to the above? So this has got to be 0. So t's got to be equal to 0, right? So press type in 0 there. Oh no. Okay, what did they do? Okay, so we got that right there, which is this line right here. All right, so what did they do next? Okay, so they factored out a 5t, not just 5. Okay, so going back to this line right here. All right, let's go back to that line right there. Okay, so on this line right here, they factored out, instead of a 5, they factored out a 5 root t, which is this right here. They're getting 1, t equals 1. What was the answer? 1. Okay, then. Okay, so they got two answers right there. So when you add them together, they get the 1. 1. All right. Okay, we just factored out the wrong thing on this question. All right, but that's the general idea. The general idea is to simplify, factor, and then add the two answers. Okay. All right, let's go to the next one. Which value of x is the solution to the above? Okay, same thing idea, same idea. Collect your like terms and then solve for x. So keep your root x's on the left side and keep your numbers on the right side. So start with this one. Start with the negative 2 root x.
Keep it on the left or
Yeah, keep that on the left and then take the negative 5 root x to the right side. How do I get my yep, equals what? 7 minus 5 or 7 plus 5?
minus
7 minus 5 is how much? There you go. Okay, so now how are we going to solve for x there? Square both sides. It's like this, right? So make sure it's like that squared, okay? 3 times 3, how much?
9
Root x times root x, how much?
x
Yep, so 9x equals 4. Okay, now what? Divide both sides by?
9
So it's b, right? Yep, good. All right, same thing on this one. So do the same thing on this one. Click your root t's on one side and your numbers on the other side. Value of t, the solution. So this one will be 8 root t, or sorry, root 8t, 4 2t. What's the sign in the middle here? 10 and 13. What's the sign here? What's the sign here? This is plus, this sign is plus, right, on the right side. So when we take it to the left side, it's going to be minus. This sign is plus 13 here. When you take it to the right side, it's going to be the opposite. So minus, minus. All right, so we know that's negative 3 there. How can we simplify the left side? We can do it like this, right? We can break them down into 2. The first one will be root 8 times root t minus 4 times root 2 times root t, right? We're just breaking the radicals down. So can we do that now? What's okay, 8 times root t minus 4 times root 2 times root t. Can we simplify that? Equals -3. If we factor out a root t, factor out the root t, so we'll have root 8 minus 4 root 2, right? Now divide both sides by this. Divide both sides by that. So you'll have root t equals -3 divided by root 8 minus 4 root 2. Can we simplify that? If we square both sides, we'll get t equals all of this squared, right? What's all that squared? What's -3 root 8 minus 4 root 2 all squared? What is that? What is that? That's going to be what? 9 over 8 minus 16 times 2, right? Just square every term there. And what is that? That's 9 over 8 minus 32. What's 8 minus 32? -24. You see what I'm doing? I'm just simplifying, right? Okay, so 9 over -24 is 3 over -8. Okay, so which is okay, so we square both sides, and then this is 3. Is that right? That's not one of the answers, though, right? So what did we do wrong? What did we do wrong there? 8 minus 32 is -24. All right, let's check the math again. So we broke down the root 8t into root 8 root t minus 4 root 2 root t, okay, equals -3. 10 minus 13 is -3. Then we factored out the root t. Then we divided both sides by root t. No, by this. And then we squared both sides. All right, what did we do wrong there? Where did we go wrong? Nine over 8 minus 16 times 2. Which is 9 over -24, which is 3 over 8. No? We can also just try plugging in these answers for t. Take the 9/16 and plug it in right there and right there to see if it checks out. We can also, test each answer. But we did something wrong there. Try picking D. I just want to see what they did. 9/8. Okay, so scroll down. Okay, what did we do wrong? What did we do wrong there? 4. Okay, I think our algebra was wrong somewhere. Did we not do the algebra right? Oh, I think we made a mistake on the algebra somewhere. But anyways, if you got a test this week, just keep practicing a few questions every day, maybe 10 questions a day. When's your test? You said Wednesday?
Yes.
Just practice maybe a few more questions later today, some tomorrow, some Monday, some Tuesday. And then you should be all right. Look, on the test on Wednesday, if you can't do a question within like a minute or two, just guess and move on, right? Don't take too long on any one question. What else? You know the material, you study several months for the material. You know the material. Just take your time, reread all the questions, reread the questions if you have to, and just do your best. That's all. Don't get nervous. Just take your time, read the questions carefully, and just answer it as best as you can. Okay. Anything else for today?
I don't think so.
All right, Ali. Good luck. Look, just keep putting the work in every day, right? Even if you do good on the test, keep putting the work in every day. If you do bad on the test, keep putting the work in every day, right? No matter what score you get, just keep consistently, right? Keep up the consistency, right? Just like anything in life. If you want to be great at it, just keep practicing every day, right? Not only math, but anything in life. If you want to be great, just keep putting the work in every day. Okay. All right. Let me know how you do, or tell your moms to let me know how you did next week. Okay.
Okay.
All right, Ali. Good luck.
All right, thank you.
See you. I'll talk to you later.